Okay, so today we will be going through the sequences once again because we had this WebEx issues last week and it was not, we couldn't come to a point of completion. So sequences are nothing but involving numbers, and all of you know numbers. Some knows from starting from 0 through however large you can. Some will know before 0, which is the negative numbers. We won't be going into those today. We want to start with 1. And a sequence of ones, for example, you all know 1. A continuation of 1 forever is something of interest. It may look very trivial to you now, but just assume or just take as the way I am saying it that it will be useful later on. Now, if someone asks you how many ones, or given 100 ones, what is the sum of those 100 ones? It's a trivial question. You know that. That's like 1 times 100 or 1 times however many numbers there are. So having said about all ones, so this is all ones. This is just FYI for your information. I mean, don't think too much into it. Now we can talk about another sequence of numbers. Is it clear, Aditya? Which is 1, 2, 3, 4, 5. Now you can guess what the next number is because you already know or figured out the pattern. 6, and then so on. So these are just counting numbers. You're just counting or increasing by 1. Now there is another category of sequences. These are all sequences because it's just a sequence. This is a sequence where nothing is changing. This is a sequence where it is increasing by 1. Now we can have another sequence which is 1, 3, 5, 7, blank. Okay. So then there is another sequence of numbers which will be starting from 1, just as the other two are, but then incrementing by 2. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, and so on. Okay. Aditya is asking me to slow down, so I'm going to slow down. So these are sequences which increase by 2. And you probably figured out another aspect is that these are all odd numbers. Odd numbers are numbers which cannot be evenly divided by 2. So that is odd. Okay. This is counting. I mean, if we continue to have the lag today, from next week, we can try out Zoom, but just bear with me for today. So these are odd sequences or sequence of odd numbers. And then there is another category of sequences, which is 2, 4, 6, 8, and like that. Those are sequences of even numbers. We will stop here. There are more, but for today's discussion, we will try to limit them until this point. Now, it is something useful, mathematically useful to know, given a sequence of numbers like this, what is the sum of them? And that is what we will be getting into today. Now, let me erase this. If I assume there is no question here, it's rather simple, but if there are, please go ahead and ask. Okay, silence is golden. I will go with my discussion today. So let's start with the odd numbers. I am picking the odd numbers. Okay, I'm picking the odd numbers because, I mean, the reasons will be obvious very soon. So the first odd number is 1. So what we will do, since we already said that we want to sum the sequences or find the sum of sequences when you are given a sequence. Now let's write the sequence here and the sum here, or rather sum here, and here we will say a pattern or formula. Formula is nothing but a easy shortcut way of getting to know or getting to do something. Okay. So the first Aditya is doing something, so good. Okay. So the first sequence, so the first number of the sequence of odd numbers is 1. And what is its sum? Easy. 1. And then let me write while the camera catches up. Line Venda. Okay. So the next will be, the next odd number is 3. So what is 1 plus 3? It is 4. 1 plus 3 plus 5. That is 9. 1 plus 3 plus 5 plus 7. Now, before I write the sum here, let's see something. Let's make an observation. Okay. Is it clear? Clear, Anna? I assume that this is clear, even though this may not stand out.
Excuse me?
Yes?
You keep freezing up.
Yes. Nothing I can do about that. So wait until the WebEx catches up with me.
Okay.
But I will try to go slow, so that, and I won't erase before Aditya is here giving me feedback. So I won't erase before you really get a chance to see it.
Okay, and is he still freezing up? Because I haven't seen him freeze up for the last minute or so.
A little. He's freezing up a little.
Okay. We should just wait a little.
Yeah, and then we can try Zoom if it starts to be really bad. So
I mean, let's just go over once again. We are talking about the sequence of odd numbers, and sum of them. Sum is SUM, sum. First odd number is 1. Its sum is obviously 1. The next odd number is 3. So the sum of those two is 4. Likewise, 1, 3, and 5, the sum is 9. And then if we go with the 7, we will get something else. Let's come here and make some observation. What is 1? Well, 1 is 1. You don't do anything about it. Now 4. Is it 2 square? Now if you see 9, that is 3 square. 1 plus 3 plus 5 plus 7, that will be 16. And that is 4 square. Okay. Now I will make a guess that if I do 1 plus 3 plus 5 plus 7 plus 9, I should get 5 square. That is my hypothesis or guess. And let's see if it is correct. 1 plus 3, 5. Good. Okay. And that is 25. Hey, I am a genius. 5 square. You agree? You all agree? If there is any disagreement or if there is something you do not understand, please speak up.
Papa, the phone time.
Say that again. Okay, it was not clear. So I mean, okay, let's continue. So I would guess that so we had one number here. 1 square is the same as 1. We had two numbers here. We have 2 square. We have 3 odd numbers, 3 square. We have 5 odd numbers. We have 5 square. So as you can see, if we have 10 odd numbers or the first 10 odd numbers, the sum will be 10 square. We haven't proved it yet, but that is our hypothesis or guess or theory. You all with me? So that is how Aditya was giving the formula. That is how we derive the formula. We make observations. We write down what we are trying to find. We try to draw some observations. And then we come up with a theory. And then we prove whether that holds well or not for any numbers. If it holds well for any number, then we know that it's a formula which will hold for any number. Now let me erase. So before I erase, speak up if you have any questions on this, what we just saw.
Does this only apply for odd numbers?
We are talking about odd numbers, so let's limit our discussion to odd numbers. Yes. Okay. Okay. So previously, what we saw is that the sum of first n odd numbers is n square. Agree? When you had just one, n was 1. When we had n1 plus 3, n is 1. 1 plus 3, n is 2. 1 plus 3 plus 5, n is 3. Like that. So that's what we mean by sum of first n odd numbers is n square. So let me erase that. Now, so if someone asks you what is the sum of first 19 odd numbers, you know what the sum is. But if someone asks you what is the sum of 1 plus 3 plus 5 plus 7 plus 9 plus 10 plus 31. Now there are two ways you can solve this. You can count how many odd numbers there are between 1 and 21 and then square it because you got the n. Otherwise, you can find n in a different way. And that is nothing but let's first prove it for a smaller set of numbers because we are all lazy people. Let's say 1 plus 3 plus 5. How many numbers are there? There are 3 numbers. And the last number, which is 5, plus 1, 6, divided by 2, 3. So that is the 3 numbers. Now, if we have 1 plus 3 plus 7 plus 9, we know there are 5 numbers, which is the last number, 9, plus 1, 10, divided by 2, 5. So we have 5 numbers. Now, if we go all the way to 23, you can count later. But what I would say is 23 plus 1, 24, divided by 2, that is 12. So you have 12 numbers, 12 odd numbers from 1 to 23 including both 1 and 20. So the formula, remember, if you remember the formula Aditya wrote last week, it is n plus 1 divided by 2
What was the last thing you said? It froze up for me, so I didn't see what you wrote.
So the last,
The n plus 1 divided by 2.
yes, that is we are trying to get to the formula to find out the sum of first few odd numbers.
Wait,
And
so
I just said the formula, but it's okay if you did not hear that, because I'm going to go over it again. Earlier, remember, I mentioned first n odd numbers. Here, there are 12 odd numbers. So n is 12 in here because there are 12 odd numbers. And I got 12 by taking the last number. Let's say the last number is L for last. I take the last number, L, and then I add 1 to it, and then divide by 2. So 23 plus 1, 24, by 2, 12. So that's how I got n equal to 12. Is that clear?
yes, thank you.
Good. Now, so if someone gives a problem to you, saying that I want to find the sum of this. This is how your question will be. And this is just not for number sense. I mean, in your school, and if you are interested in math later on, this is a very interesting or useful problem, I would say. So 1 plus 3 plus 5 up to 23. How do you find out? You take the last number, which is L. You add 1 to it because you want to find how many numbers there are, and then divide and then square the whole thing. Clear?
Okay, so basically you take the last number and you do plus 1, so 23 23 plus 1 is 24, and then you would divide it by 2 and then square it.
That is what we did. My intent of explaining all this was, now do you know why we did that? Not just you, I mean the rest everyone too. Because if you know why something is like that, then you will never forget. But if you just memorize an expression, it just stays for a day. Clear? Okay, clear.
Oh, sorry, I had a question. So this is only for odd numbers, right?
Yes.
Okay.
We will go through the odd numbers first, clear it, crystal clear, and then we will move on to the other ones.
Okay.
Now, like I said, for 1, 2, 1, 3, 5, 7, we kind of checked and we confirmed that the square formula we came up with is holding well. But how do we know if it can hold well for the next 1,000 numbers? I mean, one way would be to just do it for the other next 1,000 numbers. And when you are done, someone will ask, okay, what about the first 2,000 numbers, right? So it's never going to end. So that's where mathematicians come in, and later in your school, probably in the middle or later in or early high school, you will prove whatever we just wrote here. So at that time, you can remember us. But then let me show you another way you can prove or remember this. I just found this on YouTube the other day. Now let's say we one number, and let me represent it by a dot. So that is 1. And let me just draw a line. It will become obvious on why I am doing this. So that line I just drew so that the length here and the length here is the same. So it is a square. Now let's go for the next odd number, which is 3. So I will put 3 dots. 1 dot, 2 dot, 3 dot. So that is 3 dots. And then let me just enclose those dots by another line. My drawing is not that great, but this line and this line should be the same length because we are spacing the dots evenly. In this case, it doesn't. Bad drawing. Apologies for that. Now, the next is 5. So for 5, first let me just put the 3 dots. And then I will put 2 extra dots. So that makes it 5 dots. Good. Now the next one, 7. So for 7, 3, so I have already messed up. So this should be here. And then the next dot will be here. 1, 2, 3, 4, 5, 6, 7. So I draw another square. Can you look at this and would you agree with me would you agree with me on that? If we go just like that, it will always be a square.
Yes.
Something you can, yes. So good. So something you can try when you have time. I mean, you can do it on a piece of paper or on computer or anything. But this just shows you that no matter how many dots or how many odd dots you construct like this, it will always be a square. So this is one way you can memorize this formula. Unfortunately, when I was in school, nobody showed this because this is so clear. I mean, rather than going into the paperwork or proof of the theorem, this is like no words, just picture. So are we all good for the sum of odd numbers now? It could be the sum of first n odd numbers or sum of odd numbers where they are giving the numbers and the range. For example, what I meant is it could be 1 plus 3. Nobody is going to ask what is 1 plus 3. Probably it will be like this. 99. What is it? So in this case, this is the last number. So our L is 99. L plus 1 by 2 is 50. And 50 square is 2500. That's it. You can check this later when you have time. So this could be one kind of question, or the other kind of question could be sum of first 26 odd numbers. I say first because for this to work, it has to start from 1, and that's the first odd number. So in this case, n is 26, and the sum is nothing but n square. Clear? Okay. So we won't be releasing another video on this because I mean this pretty much explains it. Next 1 week you can look forward to quizzes where such a question is included, and just watch out for or do not get confused over the last or number and how many numbers there are. And that's the reason I just put L here instead of N. Okay, so we are good here. What timing do we have? Okay, noted. So let's now move on to the sum of sequences or counting numbers. Okay. So we are done with the odd numbers now. Moving on to the next sequence, which is 1, 2, 3, 4, and so on. It could be any number here. So we will go through the same exercise we did last time. First, because nobody, even though the formula, you can find the formula in Google today, whoever found whoever came up with the formula made some observations, wrote it down, made observation, and then that's how we got to the formula. So it's good. We should always go through that path, because then it becomes clear on why something is like something. Okay, so we do the sequences and sum, and here we will say formula. Okay, 1, sum is 1. Let me write the 1 here. 1 plus 2, the sum is 3. 1 plus 2 plus 3, the sum is what? 6. And like that. So then 1 plus 2 plus 3 plus 4, the sum will be 10. It's not very obvious on what the formula is. In the odd numbers, it was very obvious. It was just a square. And that was the reason I tried to show the odd number first. But here, let me just give you the benefit of knowing it. Let me say, if the last number is 4, say L, last number is 4, L. The sum is L plus 1 divided by 2 by 2. L plus 1 by 2 times L. Now let's see if it works. L is 4. 4 plus 1 is 5. Let's not get into the decimal. So we do this. L plus 1 by. Okay. So L is 4. 4 divided by 2 is 2. L is 4 again. 4 plus 1 is 5. So 2 times 5 is 10. And that works. Now, likewise, if I say 1 plus 2 plus 3 plus 4 plus 5. From my formula, I think it will be 5 is L here. So L plus 1 is 5 plus 1 is 6. 6 by 2 is 3. And 3 times L, which is 5, is 15. Okay. So Aditya is asking me to slow down and make it explicit. So what I'm trying to say is L is 5. L is 5. So L times L plus 1 by 2. That becomes L is 5 times 5 plus 1 by 2. Okay. So 5 times 5 plus 1. So 5 times 6 by 2, which is 15. And it is 15. So it looks like this formula will work. for the next 100 numbers. I mean, obviously we can, there has been proof out there, but this is how it is derived. Is there a visual pattern for this? There is not a neat pattern as the, yes, for the previous one, just as we saw for the previous one, but there is something close. For those who know triangles and the area of a triangle. So I have 1 dot for 1. For 2, I have 2 dots. For 3, I have 3 dots. And for 4, I will have 4 dots. Would you agree that this will always be a triangle? As we put more dots here, this line is going to go like that, and this line is going to go like that. And the last line or the base of the triangle will consist the number of dots corresponding to the last number in the sequence. And one way to visually memorize this is the area of a triangle is the base times the height divided by 2. Something close to our L times L plus 1 by 2. Something you can keep in mind, just so that you do not get confused when you have a question like this. Is it n square or is it n times n plus 1 by 2? Always remember that a counting sequence like 1, 2, 3 moves towards a triangle. Odd number is towards a square. Okay. Now to wrap up, 1 plus 2 plus 3 plus 4 plus 5. This is 5 numbers. The last number is 5, which is L. And we just said that it will be L times L plus 1 by 2. I mean, you can, there is another way to think of this. For example, what is the sum of 1 and 5? That is 6. Sum of 2 and 4, that is also 6. And then you have to deal with the 3, but you have 1, 3. This divided by 2 is a 3, and this divided by 2 is a 3. So you are basically dividing sums of the, the corresponding numbers and dividing it by 2 and multiplying by what is left in between. If it's a odd number of numbers. Let me not, we can talk about it if you want, but I do not want to get you confused. We talked about 2 sequences today. Sum of odd numbers, or sum of first n odd numbers, and sum of numbers from 1 through that number in increments of 1.